Hello, algebra students. This is a lecture on graphing of the form y equals ax squared plus bx plus c. This is section 9.2. If you recall the previous section, section 9.1, was graphing of the form y equals ax squared plus c. The difference between what we're doing today and what we did last time is that now we are going to start to incorporate a b term in our quadratics. So let's do a little bit of reviewing what section 9.1 told us. Remember, 9.1 was graphing when it looks like ax squared plus c. And we did a little web quest, and then we did a day of homework, and we learned some things about a and c. We know that if a is greater than 1, it's going to open up like this. And if a is less than, if a is negative, it's going to open down like this. If a is positive, it opens up like this, and if a is negative, it opens down. If a is between -1 and 1, so if it's like a fraction, it's going to be wider like this. And if a is greater than 1, like 2 or 3, or if it's -2 or -3, then it's going to be more narrow like this. And then we also learned some stuff about c. C is the y-intercept, but it also is what shifts us up or down. And in our web quest, we talked about what effect B has on our graphs as well. So A decides if it's open up or down, and it decides like kind of what shape it is. Is it wider? Is it more narrow? C shifts you up and down. Hopefully you guys can put together that B is what shifts left or right. So I've got a little illustration for that here. The parent function, remember the parent function is just y equals x squared. Will look like this. If a is a big number, it'll look more like this graph here, number 2. This third graph here would be if a is negative, and in this fourth graph, the c value would be like +3 at the end because it shifted up 3. One thing that I want to talk about is for all of these types of graphs, when I asked you to graph them, I made you make a t-chart with the values -2, -1, 0, 1, and 2 for x. That worked because we were always looking at a graph that did not shift to the left or to the right at all. And so a lot of the really important features of the graph occurred between -2 and 2. But that isn't always going to be the case. When we start taking this parent function, I'm going to take the parent function, I'm going to bring it down here to a different example. Oh boy. Oh, there it is. What do you know? This graph here, when we have shifted it to the left or to the right, notice that if I were to graph between -2 and 2, I don't know where the vertex is. And that's a critical part of this. Remember, the vertex is the lowest point. That's a critical part to graphing a quadratic. And so the work that we're going to have to do when we have a b term is going to change a little bit. We are no longer going to be using the x values -2, -1, 0, and 2. It's actually going to be on you guys to come up with the x values that we're going to focus on. And I'm going to show you how to do that here in the next slide. So in all of the graphs that we graphed last homework assignment, the axis of symmetry, so that imaginary vertical line that goes through the middle, was always at 0. But when we start to shift the graph to the left or to the right because of the b term, that isn't going to be always at 0 anymore. The way that you guys are going to find the axis of symmetry is using this formula right here. X is equal to -b/2a. Remember, a is going to be this number here, and b is going to be this number, so you're going to look at the formula, and you're going to pull that information and use that to find the axis of symmetry. The other thing that you guys are going to be always having to identify is the vertex. The vertex always exists on the axis of symmetry. Here's our axis of symmetry. The vertex would be where the axis of symmetry and the quadratic function, the parabola, intersect. And so the way to find the vertex, if you know the axis of symmetry, the x value is always going to be the x value of the vertex. And to find the y value, you're going to plug this number into the equation to get the y value of the vertex. I'm going to show you using this example here. So the formula for finding the axis of symmetry is negative b over 2a. And we're going to plug these numbers in. We know that, I'll just write this out here, a is 2, b is 8, and c is 5. So I'm going to plug these numbers in. I'm going to get negative 8 over 2 times 2, which is negative 8 over 4, which is negative 2. So the axis of symmetry is x equals negative 2. Once you know the axis of symmetry, you also always know the x value of the vertex. The vertex is a point, and whatever the axis of symmetry is also going to be the same as the x value of the vertex. So in our problem, the vertex is going to be negative 2 because that's what the axis of symmetry is, comma, and then we have to find out what the y value is. The way that you are going to find out what the y value is to take negative 2 and plug it in for the x's here and there. So when I do that, it's going to say y is equal to 2, negative 2 squared plus 8, negative 2 plus 5. I took whatever the axis of symmetry is, and I plugged that in for x here and here. We got to do some basic math. Negative 2 squared is 4. I'm following my order of operations perfectly, you'll notice. I can do that multiplication if I want to, negative 16 and plus 5. So I end up with y is equal to 8 minus 16 plus 5. 8 minus 16 is negative 8, and negative 8 plus 5 would be negative 3. So the y value is negative 3. That's going to be the y value of the vertex. And now I have found my axis of symmetry and my vertex. That's really the key, probably the most important thing that we're doing when we're talking about section 9.2, which is trying to graph these quadratics that have an a, b, and a c term. First step is to find the axis of symmetry, and then find the vertex. Once you have that, then we're going to end up making a t-table and plotting some points, just like you guys have been used to. But this is really how I want you guys thinking to start. Let's pass on this. Well, you guys should be able to answer the question, does the parabola open up, by looking at A. If A is positive, it opens up, and if A is negative, it opens down. Once you have done, you can kind of think about that. You don't necessarily need to. But step 2 is going to be to find and draw the axis of symmetry. Remember, the axis of symmetry is negative b over 2a. Once you know the axis of symmetry, you can always find the vertex. What you do is you just plug in negative b over 2a, and whatever you get out is going to be the y value of the vertex. And then I'm going to actually have you make a t-table and graph that, and we'll kind of see when we look at an example. So here's our example. We already know the axis of symmetry was at negative 2. That was the axis of symmetry. So I'm going to go ahead and plot my axis of symmetry with a vertical line at negative 2. The vertex is always going to be a point, and whatever the x value, whatever the axis of symmetry is going to be the x value of the vertex. And we actually already found the vertex because we already plugged negative 2 in for x. So you remember we did negative 2 squared plus 8 times negative 2 plus 5. Our calculator should be able to handle this whole line correctly. And what we came up with was negative 3. So negative 2, negative 3 is the vertex. I want to make sure that I got that right, but I believe that's what it was. Negative 2, negative 3, negative 2, negative 3. Sweet. So then we're going to go back to our handy-dandy, trusty t-table. But instead of doing negative 2, negative 1, 0, 1, and 2, we're going to put negative 2, negative 2, yikes. Let's try again. Negative 2, comma, negative 3, right in the middle. And then we're going to add 1 to negative 2. That would be actually negative 1 and then 0. And subtract 1 from negative 2 this way, negative 3, negative 4. So it should be, increasing as we go down. That's how we like to see it, with your vertex in the middle. And then we're going to simply plug in some of these x values in for x, like plug in -1. If you plug in -1, that would look like 2 times -1 squared plus 8 times -1 plus 5. Like I said before, our calculators should be able to handle that whole thing in one line. -1 squared is 1, and 1 times 2 is 2, minus 8 plus 5, and we're going to end up with -1. 2 minus 8 is -6, plus 5 would be -1. Now, we should be able to reflect that to the other side of the vertex, because that's how this axis of symmetry is working. Remember, -2, -3, and then we plugged in -1, and we got -1. We should be able to reflect that to the other side of this vertical line to right there, which is -3, -1. And now we can plug in 0. Plugging in 0 would be 2 times 0 squared plus 8 times 0 plus 5. And our calculators can handle this all in one line, but that's just going to end up with 0. That's going to be 0 plus 5. We're just going to end up with 5 there. 0, 5 is all the way up here, and we can reflect that to the other side of the axis of symmetry, or if you want to think of it as 0, 5 here, it also is going to be 5 there, -4, 5. And now we should be able to connect the dots and see our parabola. So it goes down like this through that point. There's the vertex, and then it goes up. Let's look at another example of this. I know this is a lot. So we'll take it slow. Hopefully we will understand this. This one is going to open up because the A term is positive. Step 2 says to find and draw the axis of symmetry. Remember, the formula for axis of symmetry is x equals -b divided by 2a. A is 3, we know b is -12, and we know c is 2. So I should be able to plug these numbers in. -12 is just going to be +12 over 2 times 3. 12 over 6 is 2. So our axis of symmetry in this problem is going to be right here at 2. Step 3 says to find the vertex. Remember, the vertex and the axis of symmetry are always going to have the same x value. That's going to go right here. So it's going to be 2 comma something. To find that something, what we're going to do is we're going to take 2 and we're going to plug it in for x. So we're going to have 2 squared minus 12 times 2 plus 2. Once again, our calculators can handle this full line, but so can I. 2 squared is 4, and 4 times 3 is 12, minus 24 plus 2. -12 plus 2 is -10. So our vertex in this problem is going to be correct, 2 comma -10. What I want you to do next is to make your t-table, but put 2, -10 in the middle. You're going to add 1 underneath, so add 1, 3, add 1, 4, and subtract 1 here, 1, and then 0. And then plug in either 1 or 3. I don't really care which one. I would probably do 1 if I was thinking, about it, but maybe 3 I would plug in too. It doesn't really matter. It's going to give you the same thing. 3, 1 squared minus 12 times 1 plus 2. Our calculators can handle that full line, but so can I. 1 squared is 1 times 3 is 3. Minus 12 there, because 12 times 1 is just 12. Plus 2, -9 plus 2 is -7. So when I plugged in 1, I got -7. I could reflect that over to the 3 as well, or I could have plotted 1, -7, which would have been 1, -7 here, and then I could have visually reflected it over that axis of symmetry to that point, 3, -7. Then I've got to plug in a different x value. I'll plug in 0 here. When I plug in 0, that's actually the easiest one because it makes this go away and this go away. Because 3 times 0 squared minus 12 times 0 plus 2, that's 0, that 0, you just end up with 2. So 0, 2 is right here. And then you could reflect that on the other side of the axis of symmetry, which is going to give you 4, 2. Also, if we knew this was 2, we could have reflected it here to be 2 as well, just on the other side of this vertex right there, right? That's our vertex. Then we get to play connect the dots. What an exciting game. Boom, 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 boom. Boom, 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 boom. And there's our quadratic. Let's do one more just for fun. Go ahead and pause it here. Give it a try on your own. See how you do. This parabola is going to open down. Worth noting. I'm then going to do negative b over 2a to find the axis of symmetry. X equals negative b divided by 2a. Negative b is actually going to be positive 16 because b is already negative, and negative negative makes positive, over 2 times negative 4. 16 over negative 8 is going to give me negative 2. So this one's axis of symmetry is at negative 2. If you know the axis of symmetry, guess what? You also know the x value of the vertex because they have to be the same thing. So I know it's going to be at negative 2. I just need to find the y value of the vertex. And the way that I do that is I take negative 2 and I plug it in for x there and for x there. So that would give me negative 4, negative 2 squared minus 16 times negative 2 plus 8. Negative 2 squared is 4, and 4 times negative 4 is negative 16. Yikes, that's going to give me plus 32. Because negative 16 times negative 2 is positive 32, and then plus 8. So I'm actually going to end up with negative 16 comma 24. Negative 2 comma 24, that's not great. Negative 2 comma, it's actually way up. Let's say it's somewhere up here. It's probably higher than that actually, but somewhere up there. Hopefully your guys' homework will have a good job of keeping them in the window. I also could make these all count by 2s. That would help me out a little bit, but I'm just going to leave that for now. Negative 2, 24. Remember, then you make your t-table and throw the vertex in the middle. Negative 2, 24. 1 more than negative 2 is negative 1, and 1 more than negative 1 is 0. Count down going the other way. Negative 3, negative 4. So then you plug in negative 1. See what you get out. Plugging in negative 1 is going to give me negative 4 times negative 1 squared minus 16 times negative 1 plus 8. Negative 1 squared is 1, and 1 times negative 4 is going to be negative 4. Plus 16 plus 8 is going to be negative 12. No, sorry, positive 12 plus 8 would be 20. So what we end up with when we plugged in negative 1 was 20, and we could reflect it to the other side. So up there, if up there is 28, 20 might be somewhere like here and here. The blue dot should be right there. Okay, now we're going to plug in 0 or negative 4. Doesn't really matter. Plugging in 0, though, is really nice because it just makes this go away and this go away, because plugging in 0 here makes that 0, We're just going to get 8. And now we're in our window, which is nice. Up here at 0, 8, and we could reflect that across to be right there. And then here's where our parabola is going to look like. Just like that. So hopefully this makes some sense. Please let me know if you guys have any questions. Check back in, and we'll talk some more about it. And yeah, good luck.